Good afternoon, ladies and gentlemen. Welcome to Vectors. Lesson 1. Now, a few things about vectors. You can represent a vector with an arrow. So if I go 5 meters that way, then 11 meters is twice that and a little bit more. Now remember, vectors have an amount and a direction. So 11 meters that way or 11 meters to the right works. Now, simple question. If you go 20 kilometers east and then drive another 5 kilometers, how far have you gone? Well, 20 and 5 for a total of 25 kilometers east. Okay? Now, one for you to try. If you walk 15 meters north and then turn and walk 20 meters south, how far did you go? Well, 15 meters north and you turn around and go 20 south. You've gone, your displacement is 5 meters south. Now, if you remember that plus is up and to the right, this can be minus 5 meters because you're going 5 meters south. But whatever. Now, this is one-dimensional. That's pretty straightforward. Vectors in 2 dimensions. So, you draw your vectors tip to tail. So if you go 7 kilometers east, and then 5 kilometers north, how far have you got? Or your displacement. So we're looking for the resultant. Now I need an angle. So what's the resultant? What's the length? Well, how do you solve the hypotenuse of a right angle triangle? It's a Pythagoras. Or in this case, 7 squared plus 5 squared equals resultant squared. 35 plus 25 equals the resultant squared. The resultant squared is 60. So the resultant is the square root of 60. 35. What am I smoking? 49. Forgive me. 49 plus 25. That's 74. Oh dear, oh dear, oh dear. And the square root of 74. It's approximately 8.6 kilometers. Now, you remember in Math 20, I would get very annoyed if you used a square root, if you used a decimal approximation for square root. However, in physics, 1 or 2 decimal places, I'm fine. Now, more importantly, what's the angle? Well, if this is a right angle, you have the opposite, you have the adjacent. And which trig ratio do you have? Tan of theta is the opposite, adjacent, which is 5 over 7. Now, since you have the 2 sides, theta is the inverse 5/7. Now check your calculator to make certain you're in degree mode because the TI series will go into radian if you turn them on and off. 35.5 degrees. Now, so far so good? I want you to pause the recording, double check this, make certain you've got everything, because there's one more important thing I have to talk about, but you have to know this first. So pause the tape. Okay, now welcome back. Now the thing is the angle, 35.5 degrees. Now there's one two or 2.5 ways to talk about the angle. Never eat shredded wheat. Here, we're at 35.5 degrees. So, note here, to do this, you go east, and then you swing north to make an angle of 35.5. So it's 35.5 degrees north of east. So east is the major way you go, and then you swing north. And yes, they do it backwards just to confuse you. So that's one way. The other way, which is in fact much simpler, is bearing. From the east or x-axis, going clockwise, or sorry, counterclockwise. So bearing 35.5 degrees is the simpler way to do it. Note, any of you who've been trained with a compass, you will always talk about this relative to the North Pole or north or the y-axis, and occasionally I will make that mistake talking about something relative to the y-axis. It's not. It's to the east or x-axis. So if I make that mistake, catch me and gently remind me. So far, so good? Good. Now, one last thing to point out here. This is 35.5. What's this angle here? Well, it's 90 degrees minus 35.5, which should be 54.5 degrees. Double check on your calculator. Okay. So we can write 54.5 degrees. And notice we go north, then east. So there's actually three ways to write this. 54.5 degrees east of north, 35.5 degrees north of east, or a bearing of 35.5 degrees. So I want you to review this, and then I'll stop the tape, review this, and we'll go on and do a couple more examples.